The vast majority of misspecification is due to excluding important explanatory variables from your regression model. The goal is to carefully select and include as many important explanatory variables as you can. But often, we're working with data that wasn't specifically collected to test our research questions. As a result, some misspecification due to lack of measurement of important explanatory variables may be inevitable. In this case, you seek to identify the simplest, best-fitting model that you can. The most important thing is to know where your data came from. This will help you identify the limitations of the data you are working with. It is also critical to document and report data management and analysis steps. For example, if you choose to delete some outlying observations, you should report how many you delete and why. If you choose to aggregate several variables to create one variable for analysis, then report the variables that were used to create the aggregate score. It is up to us as data analysts to make sure that we clearly state the limitations of our analysis and suggest ways in which our statistical models can be improved if those limitations could be overcome in the future. The ultimate goal is to make sure that the people that you are reporting to, or who might be reading your report, understand the limitations as well. That way, they can make a fully informed decision about how to act on the results. The last thing we would want to see is an expensive, time-consuming process implemented based on the results of a statistical analysis for which our regression model explained only a small fraction of the variability in the response variable. It's important to remember that just because we see an association in our sample, there's always a chance that we won't see it again in future samples. We need to clearly convey that statistics can't prove an association exists. Replication is the key. Ideally, if we can demonstrate an association over and over again, then we can be more confident that it truly exists in the population. Finally, the news may not always be good. Bad data will produce meaningless results. If the data you have just can't do a good job of statistically answering a research question, either because of poor measurement, not enough observations, excessive missing data, and so on, then it's important to report that information to avoid trying to answer a research question that just can't be answered with the data that's available. It's also possible that you don't find what you're looking for. For example, an analysis of drug study data might demonstrate that a new drug is no more likely to improve a disease outcome than the existing standard of care, or that an intervention designed to improve language arts test scores in elementary school students does not show a whole lot of improvement in test scores.